Hi everyone, welcome to my session on how to choose the right streaming database for Pulsar. I'm super excited to be here at this virtual Pulsar Summit. First of all, let me introduce myself. My name is Bobur. I'm a developer advocate, software engineer, and also open source Rising Wave streaming database contributor. In today's world of real-time data processing and analytics, streaming databases have become an essential tool for any businesses that want to stay ahead of the game, right? However, with so many options available in the market, choosing the right streaming database can be a daunting task. In this session, we'll go through what is a SQL streaming and streaming database, when and why to use it, and discuss some key factors that you should consider when choosing the right streaming database for your business. You can think of a stream as a sequence of events or data elements made available over time. Data streaming is a method of processing and analyzing data in real time as it is generated by various sources such as sensors, e-commerce purchases, social networks, and many more. It involves the continuous and persistent collection, processing, and delivery of the data in the form of events or the messages. Basically, you can ingest data from different data sources such as message brokers, Kafka, Pulsar, or databases like MySQL or PostgreSQL using zero change data capture, CDC in short, which is a process of identifying and capturing data changes. Once you collect data from those data sources, you can store this data in a streaming database where it can be processed and analyzed using SQL queries with SQL streaming. In the upcoming slides, I will explain to you what's a SQL streaming and streaming database. SQL streaming is a technique for processing real-time data streams using SQL queries, which is we are familiar, right? It allows the businesses to use the same SQL language they use for batch processing, to query or process the data streams in real time. One of the key benefits of SQL streaming is that it allows the businesses to leverage their existing SQL skills. As a developer, I can use my SQL skills and infrastructure to process the real-time data. This can be more efficient than having to learn new programming languages if you are not in Java or Scala or tools to work with data streams. The data can be transformed, filtered, and aggregated in real time from stream into more useful outputs like materialized views to provide insights and enable some automated decision making. Some of the benefits of, as I mentioned, using the SQL is also using the data or the queries you're familiar with. Materialized views are typically used in situations where a complex query needs to be executed frequently, or whereas a query result takes a long time to compute. And by pre-computing the result and storing it in a materialized view, or we call it like a virtual tables, and queries can be executed more quickly and with less overhead. Many relational database management systems also provide native support for materialized views. The following figure also shows an example of using this materialized view pattern to generate summary of sales, let's say data in the order item or custom tables in a separate partitions. We can generate a materialized view for containing total sales value for each product in the electronics category, along with a count of the number of customers, maybe who made these purchases of each item. To create materialized views for streaming data, you can use streaming database, also known as a real-time database. It's designed to handle a continuous stream of data in real time. It is optimized for processing and storing large volumes of data that arrive in continuous and rapid stream. Streaming database has a similarities to the traditional database, like streaming database uses the same declarative SQL and the same abstractions like tables, columns, rows, views, indexes as a traditional database. And streaming database also does almost all of its work at right time. Compared to the traditional database, they do not in the right time, right? When data flows into streaming database, it's processed automatically in real time and immediately used to update these results of any registered queries. When applications want to read the query results, they can look at all the ways that it has changed over time. Not only running the single query, it shows the data changed in all this period. What else you can do with streaming database? You can collect, transform data from different streams, data sources such as Apache Pulsar, and create materialized views for the data that needs to be incrementally aggregated. Like you can also acquire complex stream data with a simple SQL syntaxes. After aggregating and analyzing these real-time data streams, you can use real-time analytics like BI tools to trigger downstream applications. Downstream application can be your backend server or the low-code dashboard. As there are various types of streaming databases available and numerous features are provided by each. Below in this slide I have shared the most used streaming database nowadays, both open source and SaaS. Among them you can see Rising Wave or Materialized, Amazon Kinesis, of course Confluent, and so on. And to choose the streaming database for the use cases or for your infrastructure, there are some typical criteria you can follow. Like first of all, you should look at the data sources. What types of data sources that the platform can ingest and process. Make sure that the platform can handle data sources you need, like Kafka, maybe Redpanda, Pulsar, Google PubSub, mostly used as a source as for the stream services like maybe databases such as PostgreSQL and MySQL. Next, for example, it should be scalable, right? Some platforms may be limited in their ability to scale, while others can handle large volumes of data and multiple concurrent users. Make sure that scaling process can be completed quickly without interrupting data processing. For example, open source project Rising Wave dynamically does these partitions data into each computational nodes using a consistent hashing algorithm, and these compute nodes can work collaboratively by computing data and sharing this data among them. And also next consideration can be integration, because some platforms can integrate with other systems and tools such as BI or data analytics platform you're currently using. Maybe make sure that platform supports protocols, APIs that you need to connect your other systems. For example, Rising Wave has integration with many services for visualizing the data like Grafana, Metabase, or Apache Superset, and so on. Next, of course, the performance, speed and efficiency of the platform. You need to also check how is fast to analyze the data, transform, or load millions of records in the seconds. The key performance indicators like KPIs for streaming data platforms are event rate, throughput, that event rate time or event size, and look at the latency and reliability. Other three consideration from my perspective is looking at the security features of these platforms, such as access control, data encryption, or compliance certifications, that you make sure that the data is protected. And also easy of using it, like how the platform includes user interface or documentation, understandable, or active support resources or releases, and make sure that the platform is easy to use and provides adequate support for your team. And finally is cost, of course, including the license fees, maintenance cost, any additional hardware or software requirements you can consider. And make sure that the platform fits within your budget, provides a good return on investment. because if you consider the open source streaming database, it's for free, but if you want to achieve more advanced features, you go for enterprise, or you can use some cloud provider streaming databases. For example, Rising Wave works seamlessly with Pulsar to provide a real-time data streaming and processing solution, making the building and maintain real-time applications much easier. I tried myself, for example, in this quick demo, I would like to show you how to use Rising Wave to consume the Pulsar data streams and perform data analysis. We will use maybe simple Twitter data to acquire Twitter users, maybe their posted tweets. As you can see in the below schemas for tweets and Twitter users, in the tweet schema, text contains content of tweet and some dates, information at what date or time created, or this tweet was posted, and hashtags will be extracted from text. Let's try to calculate two things, like one, tweets posted by influencers with more than a certain amount of followers, and also we will try to find out top 10 hottest hashtags among these tweets. For this demo, I'm going to use Rising Wave ready demo cases and the integration folder on Rising Wave GitHub repository. If you navigate to Twitter Pulsar folder, there are 4 files. There are Docker Compose for YAML file. You can bring all necessary containers using Docker, or find some how to create a materialized view, or create a source and register the Apache Pulsar as a source, data source. And first thing, you need to open this project folder on your favorite editor. In my case, I'm using VS Code, and do Docker Compose app quickly. And it also runs all the necessary containers. So if I do Docker Compose app, here we go, and as you can see, I am using Windows operating system and Docker desktop installed on my machine, and some Rising Wave related containers have been running. Only if you look at this message queue here, actually Apache Pulsar project, and it's acting as a message broker in our case. Once you run and clone the project, next step is to also install the Postgre interactive terminal, PSQL. And in my case, I'm already installed it on my Windows machine. You can just open this PSQL terminal by running this PSQL command, and we are now in Dev Console. Next, I want to connect Rising Wave to Pulsar streams. So to do so, I need to create new source on each topic in the Apache Pulsar. So you can run the following command here, SQL command to create a source. As you can see, it's understandable by format, and there's a Twitter topic. You can assume that we are creating structure in a streaming database for this Twitter topic, and we are using the Rising Wave connector to connect the Pulsar streams, and we are reading the Twitter topic. You can also provide admin URL and the service URL. Let's run this create source Twitter SQL command. If I press and enter the terminal, as you can see, we created our first source. Next step, we create a materialized view to that maybe stores the tweets posted by influencers with more than 5,000 followers, or maybe any specific number, or maybe 500. This materialized view is a basic one. For example, you can run more complex queries and create materialized views. In this case, I am only interested number of influencers and author and tweets that has more than 500 followers. Let's create this materialized view using the Rising Wave, and I can use simple SQL query to do so. Here we go. After you connected the rising wave to Pulsar and create the materialized view, now we can try to query some tweets from this materialized view by running this simple SQL query. Let's say limit the response with 5. As you can see, I got after with 0 tweets. I have 2 afters which who has actually more than 500 followers, and with 0 tweets I got this response. Let's make this materialized view more complex in the next steps. We can also create a materialized view called hot hashtags to find out the top 10 hashtags used maybe within the last day, or we can also specify multiple days. Let's create this materialized view using the create materialized view function, and also select some hashtag accuracy and using the tumble function. So if you copy this SQL command and put it in the terminal on the same way we did, and once it's successful, it creates a new materialized view, and now we can run our next query command. If you run another SQL command, like to select from hot hashtag materialized view some rows, and as you can see, it returns us top 10 hottest or mostly used hashtags with their the timings, like most used hashtags from different days will be shown here, let's say for the multiple days. In our case, we are specifying our materialized view on a single day. As you can see how this performance are high, and we got a response back from the materialized view. So in this quick demo, you learned how to create a source and specify the rising wave connector as a Apache Pulsar, and also how to create materialized views, like to find out the most influencers on, according to tweets by the authors. Also run more complex tweets, like to find out top 10 hottest hashtags used among these tweets, and so on. I hope that you found it interesting, and now we can jump into questions. If you have further questions about how this integration works, you can also ask me. I will be available for the Q&A session. Thank you.